The next step is to check which is the cation present in the given salt. Now let's check which is the cation present in the given compound. Okay, so first we have to prepare a salt solution of the given salt. So that is what I have prepared. Already I have prepared a clear solution, a water solution of this salt. Okay, so I've added enough water, I've added salt, and you cannot see anything settle down, which means the clear solution shows that the salt is completely dissolved in water. Okay, now what is the next step? I've told you, in order to detect the presence of cation present in the given salt, we use two chemical reagents. One is sodium hydroxide and the other one is ammonium hydroxide. Okay, so first I shall start with ammonium hydroxide. So from this salt solution, I just take a little bit and I'm pouring it to another test tube. Okay, so I've taken a little bit of the salt to a salt solution to a test tube. Okay, now to this I'm going to add ammonium hydroxide solution. Ammonium hydroxide solution is added. Just see what happens. You can see the formation of a thick white precipitate. I hope you can see it, and this is a thick chalky white precipitate that you can see formed inside the test tube. Have you followed, children? It's a thick chalky white precipitate formed, and I'm going to add excess of ammonium hydroxide to it. I'm going to add excess of ammonium hydroxide. The precipitate remains. The precipitate remains, and this may be of the respective hydroxide. The metallic hydroxide is formed here. So it is a thick white precipitate formed. So as it is insoluble on excess addition of ammonium hydroxide, I can think or I can guess that there may be the presence of lead ions in this compound. And in the beginning, when I did the action of heat experiment also, I had a confusion regarding the cation present, because there was the presence of a yellow solid which got fused with the glass, and that may be of a monoxide, that may be lead monoxide, because it was a yellow colored oxide which got fused with the glass, isn't it? So here also I got a doubt, I have a doubt whether it is lead or not. Okay, now I have to do one more test, that is with sodium hydroxide. Now I am going to take a little bit of the salt solution in another test tube. The same salt solution which I have prepared in the beginning, I just pour a little bit of that salt solution to another test tube. To this test tube, I am going to add the next reagent to check the presence of the cation, and that is sodium hydroxide. I am going to add sodium hydroxide. On adding sodium hydroxide, I got a thick white precipitate. I got a thick white precipitate here. Now, on excess addition, here I think inside the test tube there was something else, and that is what you could see a slight color change. I'll do one thing, I'll take one more test tube and just do the experiment, otherwise you may feel that why the color is formed. Okay. See, I'm going to perform the same test. I've taken the salt solution in a test tube. To this I am adding sodium hydroxide. Okay. So you can see a thick chalky white precipitate formed. A thick chalky white precipitate is formed. What did I add to the salt solution? I have added sodium hydroxide. Have you seen, children? Thick chalky white precipitate is formed here also, and on excess addition, here the precipitate is thick enough and more amount of the precipitate is formed, so I have to add excess of sodium hydroxide. I am adding excess of sodium hydroxide and see what is happening. See, on excess addition of sodium hydroxide to this chalky white precipitate, you can see that the quantity of the precipitate is slowly getting reduced. which means on excess addition of sodium hydroxide, the precipitate starts to dissolve. You can see there is a clear part formed here and a part of the precipitate is dissolved, and if you add excess, taking out the precipitate, you can see that the precipitate completely dissolves. Have you followed? And that is due to the formation of a complex compound which you have already learned. It is sodium plumbite. Okay children, so here we have seen that on adding sodium hydroxide to the salt solution, a chalky white precipitate is formed, and again on excess addition of sodium hydroxide, the precipitate dissolves. But when ammonium hydroxide is added to the salt solution, chalky white precipitate is formed which is insoluble on excess addition. That is what we have seen. Now you have a clear picture regarding the cation that it may be lead. Now again we have to do two confirmatory tests in order to confirm whether the cation present is lead or not. For that I am going to take a little bit of the salt solution again. To this salt solution I will be adding dilute hydrochloric acid. Okay, so first I added ammonium hydroxide, I got a chalky white precipitate, and then I added sodium hydroxide, there also I got a chalky white precipitate, and these precipitates were soluble in the case of excess addition of sodium hydroxide, insoluble on excess addition of ammonium hydroxide. Now to this salt solution I am going to add dilute hydrochloric acid. I am going to add dilute hydrochloric acid. Whenever you take a reagent bottle from the reagent shelf, my dear children, it should be replaced. Okay, immediately. After use, it should be closed and then should be replaced. Now I am going to add dilute hydrochloric acid to this salt solution. See, again you can see the formation of a white precipitate. What did I add? To the given salt solution, I added dilute hydrochloric acid. Then also a white precipitate is formed. And I think you can understand what is this white precipitate of. In the other cases, the white precipitate, chalky white precipitate was of lead hydroxide, and here the white precipitate formed on adding dilute hydrochloric acid to the salt solution is lead chloride. It is lead chloride, and we have learned something about lead chloride. And do you remember what is that? Lead chloride is a white precipitate which is soluble in hot water and it reappears on cooling. Isn't it children? That's what we have studied regarding lead chloride. So let us try heating this compound. Okay, and use the blue part of the flame so that the heating will be perfect. Okay, so now I am heating this mixture. Here I had a precipitate and that was of lead chloride, and I am heating lead chloride. See what happens here. And see children, always I think you might have noted that never I face this test tube towards me. It's always kept away from my face, which means that is the method that you have to hold, otherwise it may cause some problems, like it may cause burns. Okay, so on heating this lead chloride white precipitate, what is happening children? So you can see it's dissolving. A bit more is left behind at the bottom. So let me heat it. So on heating lead chloride, or normally you can see here, for my convenience I heat it. Otherwise what can you do? You can add hot boiling water to this particular precipitate, and the precipitate dissolves immediately if only precipitate is present. Here the presence of water is also there, and that is what it's taking time. Otherwise it dissolves very quickly. Okay, so now you can see the precipitate is dissolving. Have you followed? You can see the clear solution formed there, and again at the bottom a bit more is there, and if you continue heating for a long time, the entire precipitate dissolves. But the other thing is, when you keep it for cooling, what happens? The precipitate will reappear. Okay, so slowly you can see the precipitate, the quantity of precipitate is getting reduced, and finally it totally dissolves. Have you followed children? So that is about lead chloride. Okay, so now we have almost confirmed the presence of lead in the given compound. There is one more final confirmatory test to confirm the presence of lead in the given compound, and that is what you call as Golden Spangles test. You call it as Golden Spangles test, which is very interesting, at the same time very colorful. Okay, so let us check how to perform this Golden Spangles test. Okay, so here I have the salt solution with me. This is of the given compound. To this given salt solution, I am going to add lead. This is lead, compound of lead. I am going to add potassium iodide solution. What am I going to add to this compound, children? I am going to add potassium iodide solution. Potassium iodide solution is also a colorless liquid. Okay, so here I have potassium iodide solution with me. It's a colorless liquid. Okay, to this colorless salt solution, I am going to add potassium iodide solution. Just look into the test tube. See what happens. There is a golden yellow colored precipitate formed. Okay, on adding potassium iodide to the salt solution, if it is lead, there will be the presence of yellow precipitate. Have you seen? And this is of lead iodide. The yellow precipitate formed here is lead iodide. And as I have said, lead chloride dissolves. It's a white, lead chloride is a white precipitate. We have seen it right now. It dissolves on heating. That means it dissolves in hot water and reappears on cooling. The same thing happens here also. Lead iodide dissolves when hot water is poured to it. Okay, and it reappears as golden spangles on cooling. Reappears as golden spangles on cooling. So I'll be adding a little bit of hot water to it. Or you can also do another thing. Let me add, for my convenience, not to save time, let me add a little bit of water to this. Okay, and then let it be heated. Normally we do this experiment keeping in a water bath. Water bath means it can be placed in a beaker containing water, and the entire beaker with water and the test tube will be heated until the precipitate inside dissolves. That is a time-taking process. So in order to save time, let me just heat this compound. The precipitate should get dissolved, and once when it is completely dissolved, we have to keep it for cooling. Okay, on keeping it for cooling, you'll be able to see some kind of glitters formed inside the test tube. Small glitters will be formed inside the test tube, and that is why you call it as golden colored glitters will be seen inside. That's why you call this experiment as Golden Spangles test. Okay, and this test confirms the presence of lead in a given compound. Okay, so once when you get a yellow colored precipitate here itself, you can confirm that there is the presence of lead in it. Okay, and once when this Golden Spangles test is performed, it gives you a clear idea, or it confirms the presence of lead. Have you followed, children? So it's almost dissolved. I'm not waiting for getting it completely dissolved. So it is almost dissolved. Now let's keep it for cooling. Okay, let's keep it for cooling. Let it get cooled. On cooling, you'll be able to see small golden colored glitters formed inside the test tube. Actually, the same thing is getting recrystallized out as golden spangles. Okay. Okay, so let it get cooled. The reaction will be more perfect if it is done in a water bath. Okay, so let it get cooled. So this is how we perform, or this is how we identify an unknown salt, and that is why you give the name of this particular method as salt analysis. We analyze the given salt well, that is, we analyze the cationic part as well as the anionic part. We identify which is a cation and anion and name the given compound. As here we have identified nitrate as the anion, lead as a cation, and the given compound is lead nitrate. Okay, so by the time, so we have already completed identifying the given salt. I think it's clear to all of you. Now let me just show you one or two experiments which would be helpful for your theory part. Okay, that is nothing but just adding Nessler's reagent. We have already learned Nessler's reagent, K2HgI4. So here I have Nessler's reagent with me. Now, Nessler's reagent, we have learned that whenever ammonium ion is present in a given compound, it can be detected with the presence of using a chemical reagent called Nessler's reagent, isn't it? So here I have ammonium hydroxide with me. It consists of ammonium ions in it. To this compound, I'm going to add 1 or 2 drops of Nessler's reagent. See what happens, children. Have you seen? A brown colored precipitate is formed. So this precipitation will be seen only if ammonium ions are present in the given compound. Okay, so Nessler's reagent is a chemical reagent which is used to detect the presence of ammonium ions in a given compound. If ammonium ions are present, this kind of coloration, brown colored precipitate will be seen. Okay, so this is just an added information. As you haven't seen how Nessler's reagent works, I have just shown you. Now, one more test I'll just show you, children. We have seen that whenever a metal carbonate or a bicarbonate comes in contact with dilute acids. Whenever a metal carbonate or a bicarbonate comes in contact with a dilute acid, there will be strong effervescence seen, isn't it? I'll just show you how is that strong effervescence formed. Here I have taken a white colored compound, and this is another method. I'll tell you how can I check whether carbonate is present in it or not. I told you, children, dilute sulfuric acid. Dilute sulfuric acid is a reagent which help you to test the presence of carbonate ion in a given compound. So here I have taken a metal carbonate. Okay, I'm telling you in advance, I've taken a metal carbonate. Now I'm adding a little bit of the given carbonate into the test tube. Look into the test tube. Inside the test tube I have dilute acid, dilute sulfuric acid. You can see the effervescence. Okay, hope you have seen the effervescence here. Okay, have you seen the bubbles evolved? Okay, until the acid is completely used up, and here the reaction will be a bit slow. The reason is due to the formation of calcium sulfate. Okay, here I have taken calcium carbonate, so it is added to dilute sulfuric acid, so calcium sulfate is formed. Calcium sulfate is an insoluble salt, so that is why the reaction comes to completion very quickly. Okay, I hope you have seen the effervescence. So whenever a metal carbonate or bicarbonate comes in contact with the dilute acid, there will be strong effervescence. It's a colorless, odorless gas evolved. Okay, so I hope you have understood how to perform salt analysis, and also simple tests are also shown here. So thank you, children. Thank you very much. The salt, it's not completely cooled. Slightly there is a golden colored spangles seen, but it is not perfectly formed. It's a time taking process, as I said. It can be kept inside a beaker containing water for a long time so that the spangles will reappear. Slightly it is seen. There is a slight formation, but it's not clearly evolved. But I think you can see, if you look closely, you will be able to see actually the spangles will be a bit more bigger. And as I said, it takes time. It should get cooled. And I can see the spangles inside. I can see the spangles inside, children. Slightly it is formed. Okay, the test tube is still hot. That is the reason it should get perfectly cooled, so spangle size will be a bit more bigger.